if you get one. Okay, we're gonna try that this semester, see how it works. I think it might work well because the lecture can flow more seamlessly that way. If you have a question, ask. All right, I can guarantee you if you have a question, there's probably 4 other people that have the exact same question in the room. So don't hesitate to ask questions. Don't wait until you're lost. You guys, one of the things that I see a lot of the times I'll call on someone, and I'll say, oh, Michael, what's your question? And you'll be like, how do you know? And what it is, I see people go like this. They'll be taking notes and they'll go, and then they do this, they go. I don't know why people think if they sit up straighter, they will understand more. But everybody does it. They just, and I call it the prairie dog look. It's like you're looking and I see a whack-a-mole effect, like when people don't understand. So I don't know why it happens, but it does, and it's really funny. So yeah. Oh, please, yeah, please use all your tools as necessary. Also, I should add this to the thing. Oh, can you add this to the thing? Don't be stingy in terms of size with your notes. I would take, until you get used to this, take a whole damn page and make a note, because people, for some reason, will try to do really, they'll do their notes, like if this is their page, they'll do their notes like this, 1 note, 2 notes, 3 notes, 4. They get home, they can't understand anything they do. Okay? So draw nice and large, and you will be happier. Yes?
Was the sketchpad that came when our kids can use for our notes?
Not actually, but you could if you wanted to. I would just get some paper like this, or get some kind of pad that is unlined, because you're going to be adding a lot of lines to these, and you're going to want to keep it neat. One of the things also, those of you guys that are on the extreme sides, in future teams, I may have you get, like this team, move back a table from now on, because what happens is when you're seeing from extreme angles, you guys will be seeing it in front of you going, is that right? And it won't look right until you're over here. You see what I mean? Because you're seeing it in perspective, actually. Yeah. Yeah, that's my stuff, yeah. I was showing some things. Yeah. All right, so let's talk about how easy this actually is. Oh, and I have to introduce you to Delilah. You guys, this is Delilah. She's anorexic. We'll spend a lot of time with her. Okay? She's easy to move around, but she represents a person. Okay, and I just don't want to draw the whole person. Or she represents any kind of measurement that we need. So, all of you guys at some point, if you've done any reading at all in the perspective stuff, you will at some point have seen these fancy grids that, that perspective authors like to show, oh, you can do this whole, basically Renaissance type stuff, where it shows this gridded floor going back to infinity and beyond. You know what I mean? Okay. When I was first learning how to do perspective, and I was drawing comic books and such, I thought, oh, okay, you draw that gridded floor, and that allows you to move things around. Because notice that if you had the gridded floor, it'd be easier to draw a cube coming out of one of those squares, right? Well, that's okay, but it's also laborious, okay? And you don't have to do it. Here's how easy it is to move. Okay, we're going to be moving cubes. But right now, imagine we're just moving the height of the cube. Imagine there's a cube attached to this. We'll talk about how to do that later. But forget about that. Let's just imagine we're moving the front edge of a cube. It's the same problem. If you can move the front edge of the cube, you can move the whole cube. You see what I mean? Here's how it works. This is the eye level. The eye level is the height of your viewer. Okay, we'll talk more about that in a little bit of time. But that's the height of my viewer in that picture. So I'm looking slightly down on Delilah, so to speak. All right. You guys are lucky you're the first class. By the time I get to the third class, my lectures get really weird. I start entertaining myself. It's weird. All right, so here's how easy it is, you guys. I want to take Delilah, and I want to put her here. Now, you can know certain things. Like I can look at this and I can tell you she's going to be just about half as big, and I'll explain why later. All right? But I want to put her there. Now watch, everyone, stop taking notes for a second and just watch. This is how easy it is. Wait, let me get my pants. There it is. This is how easy it is. Oh, and tell me if I ever go off the screen or it goes out of focus. Delilah's on the ground plane. The X is on the ground plane, where I want her to be. I connect the two. Wait, keep looking up. I don't look down. Eyes up. So I make a reference point. Okay? And then I go like this. She's that big. That's all there is to it. Okay, take notes. All right, so that's how you move anything. That's how you move a car. That's how you move a person. That's how you move a bouncing ball. That's how you figure out how big it is at that new depth. You use a reference point. You find a common plane, the ground plane in this case, and you just go whoop, and move it to that location. Yeah?
So you can move the X around any way.
Anywhere you want. I will show you that. I'm glad you asked that question. Okay, I'm going to let people finish taking notes on that. So you draw to the eye level, you intersect the eye level, and you call it a reference point. In this case, reference point 1, because it's my first one. Yeah?
Is the eye level the same as the horizon?
Yes. The eye level is the same as the horizon, and this is a good question. Why would I call it an eye level rather than a horizon? This is a semantics thing.
It could be in space.
Yeah, exactly. You could be in space, you could be underwater, you could be in the fog. There are times where, there are many times where you will have an eye level, but you won't have a horizon. So I just like to be clear on that. But yeah, if you guys are at the beach and you look out to the ocean, that's your eye level. If you're up in a jet at 35,000 feet, you look out over the Nevada desert or something, your eye level will be right there, cutting through the window. Okay? At the horizon. All right, now, so we had that nice, interesting question from the back of the room, can you do this anywhere? What if you want to move her down? Okay, watch. What if I wanted to put her over here and you go like this? Damn it. Okay, watch. It works in reverse too. You can bring something forward. Here's the key, you guys. Take a look at this. Watch. Everyone watch for one more second. These lines, okay, everyone take a look. These lines are parallel, correct? They go to the eye level, correct? It's no difference than railroad tracks made vertically. See what I mean? It's a fence. And if you go like this, any line I draw, watch carefully here for a second, then I'll let you draw. This is Delilah's height at any of these locations. So these two lines essentially become a ruler going back into space that gives you, if she's 5 feet tall, it gives you 5 feet tall, going as far back as you want. Okay, go ahead and take notes on that. Yeah.
How did you know how to make it like taller?
How to make it taller?
Yeah.
What I did was I took a common point and a common point. I connected them, found the reference point, came back through the top of her, and it extends it forward. Yeah. I'm glad you asked that question, because we're going to do that next. It's so gratifying when you guys ask the question right before I'm about to say, because that means it's like a good, well-organized question. Now, Kimmy, I want to ask you a question though before I do. So when you say there's no common point, what do you mean?
Like, what if that you didn't draw out smaller?
What if I didn't have that one?
Yeah.
Okay, I'll show you. Actually, I'll show you that in like 3 more minutes. That's what I was, that's why I was asking Kimmy that question is, what if she suddenly started levitating? What do we do? That's where I'm going next, actually. We'll in time. Okay, so let me show you guys a couple more ways we can play around with this, but this is just, you could almost just call them moving. I'll probably call this something fancier for the notebook, like, scaling a height with a reference point or something like that, but, really, this diagram is about moving things, okay? Now, so what if you had something like this? We want to put her over here. Neither one of these are convenient, right? And there are probably some other ways I've already shown you guys that you guys can figure this out, but okay, I know she's going to be standing vertically. But how do I determine her height if these two heights are inconvenient, this one is convenient? I can go like this. Everyone watch. It's going to happen very quickly. Watch carefully. I bring her location over until I intersect that line. Draw vertical. Bring it back. She's that tall. Yeah. Now, why does that work? It works because, take a look at me for a second. If I'm visually this big, and I do this, I get bigger. If I do this, I get smaller. But if I go like this, I don't change size. So scale only changes with depth. All right? If the depth doesn't change, the scale doesn't change. This is the best version of this lecture I've ever given. This is it's so much easier right now. I like how I'm reorganizing. All right, now, everybody good so far? You see how easy this is? It's really easy. I mean, it looks you get complex results, but the basic thing is really easy. Now, let's take our original Delilah again. All right? So Delilah's standing there, minding her own business. And she gets attacked by a snake. Okay? She falls over dead. Or stunned. Maybe it's just fright. I don't know. Okay, so she falls over. She happens to fall over sideways. Not towards us, not away from us. Okay? So she's going to be laying down on that line. How long will she be? Yeah, you can do this a couple ways. You could either take your wonderful dividers. By the way, these are called dividers, you guys. They look like a stupid compass, but they're actually, these are the most useful tool you will ever use. All right.
Oh my God.
Now, here's why they're useful. These are the things that, like, you guys have probably seen these in some old war movie where, you know, they're out there and the navigator goes, how are you? Like, and the guy's going like this on a map. We're not gonna make it, Captain. You know. Okay, that's what these are great for. These are wonderful for when you want to transfer a measurement without marking things up. You know what I mean? Like leaving, you know, lines all over your page. What they can be used for, take a look. You can take them, very easily mark a measurement. Like this is the height of Delilah at that location. Watch carefully. So this is the height of Delilah, and you just go like this. And you say, okay. When she falls over dead, she's that big. All right. Here's the way I'd like you to think about this. The hands of a clock. If they're rotating around the center of the clock, they don't change their length visually. They just rotate. Their depth is not changing. Their depth is not changing, so their scale does not change. Their size does not change visually. Okay. Now, we're not going to go there today, but if I wanted her to fall in some other direction, what I'd have to do is I'd have to do this. You see what I mean? Like if she were a swinging door or something like that, and it fell over, well then I'd have to have an elliptical base to know how long she was. Okay. Now, I want you to notice something else though. Okay. If I do this is a random thing I haven't included in the past, but I kind of like including it here. If I take this distance and I divide it in half, that's about halfway. Okay? Meaning this is about halfway to the eye level from her location. Everybody watch this. This is something that's people are gonna get lost. Or if you get confused on this, it's not the end of the world. We're gonna revisit it later on. But this spot right here is about halfway for Delilah to the eye level. You see what I mean? You know, she's right here, halfway to the eye level is about there. If I go like this, that Delilah is half as big. Watch. Okay? She's half as big because she's half again closer to the eye level. And wait, one last thing. It also means if right here, if this Delilah is 20 feet away, this Delilah is 40 feet away. and you can know it. It is true. Absolutely. If you go halfway to the eye level with anything, if you take like your first cube that you drew, if you have an eye level here and then you move it halfway to the eye level, that second cube is going to be half as big and it's going to be twice as far away. Okay, there's a relationship there. Okay, take any notes you need. Yeah.
Oh, I want to clarify because some people might misunderstand.
Sure.
Because like, half is big mean half is big in vision, not
Yeah.
half is big in size.
Yeah, that's correct. The visual size is half as big. While you guys are taking notes, I'm going to tell you a stupid story. There was this Betty Edwards, who was this well-known drawing teacher. She took her daughter to the airport to see grandma off, and her 3-year-old was watching as grandma. This is obviously pre-9/11 days. Her daughter was with grandma, and then grandma goes down the ramp, gets on the plane. She watches the plane taxi. She watches the plane take off, and she's just like glued to the window. And after she watches the plane until it vanishes from sight, and she turns around and asks her mom, "If grandma gets smaller when she goes away, will she get bigger when she comes back?" That's a brilliant kid. So now with the reason I like doing this way, the reason I'm pleased with how I've reorganized this is really basic knowledge that all of you guys should have kind of intuitively. For instance, okay, like I'm standing this distance from Joe, okay? If Joe's head is whatever size it is, and let's say I'm in a cafe and I'm drawing you guys, or and if I'm drawing Joe and his head is this big, Meg's is twice, Matt's.
Yeah.
Matt's is twice as far away from me as he is. Her head is going to be approximately half the size, because she's twice as far away. So if I've drawn him this big, I can start her head just by doing it half the size, and I know it's damn close. Yeah. You guys, this stuff it's superpower type stuff. These are like the secret weapons of drawing. And I want you to know that this is how this relates to drawings that you do in class. You can know these things because they're absolute. All right? Does anybody have any questions about this before we move on? Yeah.
What if the space is circular, like it's like a mountain?
So it's a curved shape? You mean like in terms of moving it, or space, or what?
Like the ground is not that.
That's a good man. I'm so impressed you guys are even asking these questions. Okay, I think if I have time. Hold that thought. I'm going to try and find time at the end of the lecture to explain that. Because that's like about a week 7 question. But it's really, no, shoot. Should I take it? Okay, we're going to do it fast. I got 2 things to show you. And this one actually may help you with the next one too. So you got, okay, so what if, instead of falling over dead, what if she was a superhero and she levitated out of harm's way? So now Delilah's a superhero. Now, how much higher in the air do you want her to go? Well, let's make it easy on us. Let's say she goes up, let's say she's 5 feet tall, and we want her to go up 2.5 feet. Okay? And I'm going to draw her in red just because it's starting to get confusing. What I could do is I could take her, take the half height. If she's 5 feet tall and that's 2.5 feet, then I just go like this. And she's floating above that spot on the ground. So again, if the depth doesn't change, I can move, if this is if this appears to be a 12-inch ruler and I go like this to it, the depth isn't changing. Okay? So you just would You'd find her height at that location on the ground and you just move her up. Or if she was standing in a hole, if she fell in a hole, you know, you move her down. Same thing. All right, now we're gonna get into bonus material. Yeah.
If she was like floating and she moved back in space.
You would do one, then do the other.
Okay.
So for instance, if I wanted to move her to here and then have her float, I'd move her to here and then take this height and go, you know, like that. All right, so you guys, this next diagram is bonus material. We're not gonna record it or anything, okay?
Oh, wait, we don't have.
This one, we'll do this one again in a few weeks. I just wanna show you guys how it works if the ground is not level. Yeah.
No notes?
What?
No notes?
You can take the notes if you want, but we'll be doing it again later. I just want to answer Katarina's question because it's such a good question. And I'm going to do this very fast, so if you don't get this, don't worry about it. So, here's an eye level. Here's a road. Now, what if that road is going up and down, which is essentially the same thing as Delilah going up and down? Like if actually I can show, oh, this will be cool, actually. Do you want to go up or down first? Up, okay. Do you want to curve? And then if we go down again, and we curve back, I'll put it there. So here's VP1, VP2, VP3, notice they are no longer on the eye level. Watch, actually everyone just watch this, you'll understand it when I do this. I'm gonna pick a point arbitrarily where I want the road to change. Pick a point arbitrarily where I want it to change. And what you end up with is you end up with a road that does this. Goes uphill. And then goes downhill. Like that. Now, if Delilah's there, watch, this is cool. So if Delilah's here, and she's on the side of the road, and then we want her to run up the road, or let's say we have to do an animation of her running down this road, we just go like this. She's this tall here. She's this tall up here. This tall here. This tall here. And then as she goes down, her head vanishes right there. Just move her around. It's the cool thing about teaching this class, you guys, is I can see the looks on some of the faces already where you guys are like, why hasn't anyone ever shown me this? That's why I love teaching this class, because they should have. Because it's easy. You see, does this make sense?
Yeah.
It's obvious once you see it. Like, how did I not know that? You know, now, anybody have any questions? Yeah.
We're allowed to take pictures.
Yes. Yeah, I'll set them to the side and you guys can take photos of them later. Yeah.
Assuming the road is still converging the horizon, would it end up going to, you know, a vanishing point on the horizon?
Well, these are effectively vanishing points on the horizon. They just go up and down. We'll talk more about it when we get to slopes. It'll make more sense. But anyway, yeah, you guys, this stuff it's easy. All right. Now we're going to shift gears a little bit. Now you guys know how to move things, okay? But how do you know something's a square? You know, if I do this, I might have already done this to you guys. I can't remember. So if I do this.